So we start with the examples of bisection method. Just we will read the theory. Suppose we have to find out the root of the equation. Fx is equal to x cube minus x minus 4. Fine. Lying in the interval 1, 2. So this is a question. Is my screen visible?
Yes, ma'am.
Okay, fine. So since it's saying lying in the interval, we will again cross check. It may be possible that at the end point the signs are not opposite. Then directly we can say by bisection method we can't proceed toward the root of the equation, which happens next to impossible in every question. But still, then you have to cross check it. Okay. So we'll find out the value of f1. That would be 1 minus 1 minus 4, which would be less than 0. We check the value of f2. 2 cube minus 2 minus 4. So this would be 2, which is positive. So at the end point, we have f1, f2 is less than 0. Clear?
Yes, ma'am.
So therefore, root lies in the interval 1 to 2. Now, next we have to repeatedly apply the bisection method, which is based on intermediate value theorem. So I can also write in the form of table, like since you see in the question there is nothing mentioning about the number of iterations. So this is the first question. I will go up to 10 iteration maximum. But in the question, if it is mentioned, you have to go according to that. Okay.
Yes, ma'am.
Let n stand for the number of iteration. An is your first number, Bn is other endpoint, Pn is the approximation to the root, and we will cross check the sign of f of Pn and f of An. Depending upon that, we will find out the next interval for the iteration. So in the case of first iteration, A1 is 1 and B1 is 2. Okay, so Pn comes out to be 1.5. Fine.
Yes, ma'am.
So we find out the sign of f of Tn and f of An. Since I have done this calculation, so I am just showing you the result. But when you will be solving the question, you have to do this all in your rough work. Okay? It's not ki directly I am just doing mentally or whatever. It's very compact. I am just writing down. I did the calculation and that's why I am writing down. Okay?
Okay, ma'am.
So we check the sign of f of Pn and f of An. This comes out to be positive. It means the root will lie in 1.5 to 2. Interval clear?
Yes, ma'am.
So in second iteration, my interval would be 1.5 to 2. Now I will again calculate Pn. That would be 1.75. Fine. So again, I will cross check the sign f of 1.75 and f of An, that is f of 1.5. This again comes out to be positive. Clear? So it means again my root will lie in 1.75 to 2. Yes?
Yes, ma'am.
So my next interval would be 1.75 to 2. Okay?
Yes, ma'am.
So again I will calculate Pn. So this comes out to be 1.875. So I will cross check the value of f of 1.875 and f of 2. That is f of Pn is 1.875 and f of An is 1.75. I just calculate those values and multiply it, and I will find out at my third iteration it is less than 0. Okay?
Yes, ma'am.
So I'm just writing down the calculation. So just go through it. If you have any problem, you can ask me, because I have summarized the result in the summary form. Calculation has to be done. So depending upon each and every calculation, the next interval would be decided. Clear? So you
Yes, ma'am.
can, consequently, depending upon the sign, I am taking up the values. Fine. Are you visualizing the result?
Yes, ma'am.
So it's f of an, then it's f of, this is bn value, and then I will again calculate the midpoint. That comes out to be 1.796875. Calculating their product value, it comes out to be less than 0. Fine. So again it means bn point would be shifted. So our next bn would be 1.796875. Again we will find out the midpoint. I just want to show you something, that's why I am going up to 10 iteration, because there is a certain symmetry there. It's 1.7890,625, 1.796875, and this is 1.792969, which again comes out to be positive. So at ninth iteration, I am having 1.792969, then 1.796875, then 1.794922, which again comes out to be positive. So at the 10th iteration, I would be at 1.79492 7. It's 1.796875, and this is 1.795898. Now these are the result of the 10 iteration with bisection method. You just go through the values of Pn and observe it till you see sixth, not seven, till seventh iteration the value was 1.789. The value was changing, earlier 1.5 approximation, then 1.75, then 1.87, then 1.81, then 1.781. But after 7th iteration, you can see in 8th, 9th and 10th iteration, the two places after the decimal point are same. Are you able to visualize?
Yes, ma'am.
We are getting in the last three iteration, from the bottom last three iteration, the value of approximation is 1.79. It means we are now very much close to the exact root, because after this we have fixed up two decimal points. So it may be asked in the question, do the iteration till you have the correct value up to two decimal point. If I have a correct value up to two decimal point, then I can stop at ninth, because at 8th and 9th I am getting consecutively two decimal places same. Clear?
Yes, ma'am.
So at the ninth iteration, my answer is correct up to two decimal places. So the question may be asked, instead of writing down the number of iteration, it may be asked, find the root of the following equation, correct up to two decimal place. It means in this case, I don't know, but while calculating, I would be able to find out that I have to go up to 9 iteration. Clear?
Yes, ma'am.
So since I have gone up to 10 iterations, so I have to write down the sum up also. I can't leave the question here, because question has asked me to find out the approximate root. So I will write down the approximate root is, you have to write down the conclusion also, 1.79589. Fine. This is after 10 iteration. The approximate root is 1.795898. Clear?
Yes, ma'am.
Fine. So this is the way you have to do the bisection method. So you can once for a second go through this question, and if you have any query you can ask. Then otherwise I will switch over to the next question.
Ma'am.
Yes.
मैम इन द 10th इटरेशन नो मैम एन में जो लास्ट डेसिमल वैल्यू है वो 2 नहीं होगा मैम.
Could you please repeat your question? I'm not able to hear that.
Ma'am, I was saying that in the 10th iteration,
Yeah,
The value of an is not the same as pn, ma'am. Like the last
yeah,
decimal place is different.
yeah. Actually, it may be there. There might be something. You have to just cross check it. Cross check it because it's just the calculation which is coming out. Whatever is calculation, you have to write there. I can't
Okay, ma'am.
directly say it should be like this because above it is 29, at 8th it is 2969, then it's 4922. So maybe at 10th iteration there may be some calculation mistake. It should be 5023 or it should be 3025. I can't say at random now. I have to cross check it. Okay. So if it's written there
Okay, ma'am.
1.795898, so you just have to cross check. It's just a mere calculation. It's not we can finalize certain hypothesis based on this, it can't come or whatever. If it is not coming, you have to just cross check it whether it is coming or not. If it is there, then it's okay. If there is some other calculation which is coming, you just again overwrite it. Clear?
Okay, ma'am. Yes, ma'am. Yes, ma'am.
Fine. So any other question? Yes. So shall we proceed toward the next question?
Yes, ma'am.
So now suppose we are given perform 5 iterations, not explicitly they are saying perform 5 iterations of bisection method to obtain the smallest positive root of equation. Fine. So this is fx is equal to x cube minus 5x plus 1 is equal to 0. Fine. So that
Yes,
is
ma'am.
perform 5 iteration of bisection method to obtain the smallest positive root of the equation fx is equal to x cube minus 5x plus 1 is equal to 0. Okay. Now you see,
Yes, ma'am.
one thing it's saying 5 iteration and second is smallest positive root. Are you getting these two adjectives? Yes.
Yes, ma'am. Yes,
So you
ma'am.
have to do the 5 iteration as well as smallest positive root. Now it's not mentioned. You see the interval is not there. It means by hit and trial method you have to find out the interval also. In question it's not mentioned. So for that we will start say 0 nikalenge. Well, let's find out f of 0. Let's find out f of 1. Let's see. So it's hit and trial method. So f0 is 0 minus 0 plus 1, that is 1. Positive. Yes or
Yes,
no?
ma'am.
F
Yes,
of
ma'am.
1 would be minus 5. Negative. Clear? So it since it was
Yes, ma'am.
saying smallest, so we take a point closest to the origin because we need a smallest. I can't take F11, F15 because in question it's mentioned smallest. So I will try to go towards the origin side. So it means root lies in the interval and it's also saying positive. So that's why I didn't try for f of minus 1 because minus 1 would be on the opposite side. Yes.
Yes, ma'am.
So I tried just because positivity there. So on the right hand side of the origin, smallest is there and the close to origin. So are you getting these 2 points? Yes.
Ma'am, can you please repeat once? I got
Yeah,
a little
sure.
confused.
Sure. I am saying in question it is written there smallest positive root of the equation. Okay.
Yes, ma'am.
So smallest means what you will mean by smallest means I would be saying preferably or closest to 0 point, that would be smallest. Number line में which
Yes,
one
ma'am.
would be the smallest? Will be really close to 0.
Yes, ma'am.
And since it's positive side, so I will go on this side rather than on this side.
Yes, ma'am.
So instead I first try for 0, then I tried for next integer value 1. It's not necessary you try 1 because after calculating the value, I would be finding out what is the answer. You can go for 0.1 also, you can go for 0.2. It's your just jurisdiction. What do you want? Okay.
Yes, ma'am.
So in view of smallest positive root, I try 0 and 1. That's what I just want to emphasize. Is it okay?
Yes, ma'am.
So the root lies in the interval 0 to 1. Now I can form the table of bisection method. A and number of n stands for number of iteration. A and first point, B and second point, P and approximation. I will check the sign of f of Pn and f of A. Fine till now?
Yes, ma'am.
So let's start with the calculation. When n is 1, A is 0, B is 1, midpoint is 0.5. So you have to find out the value of f of 0.5 and f of 0. So multiplying these two, what I just evaluated, that is less than 0. Clear? So on the base
Yes,
of
ma'am.
this, it means that my next interval would be, since Pn and An, they are of the same sign. So my next interval would be
0 to 0.5.
0 to 0.5. Clear?
Yes, ma'am.
Now from 0 to 0.5, again I will find out the midpoint, that is 0.25. Then I cross check the sign multiplication of f of Pn and f of An, which comes out to be again negative. So according to bisection method, again my interval, next interval would be 0 to 0.25.
Yes, ma'am.
So next midpoint 0.125, this comes out to be same sign. Now it's in same sign, now the interval will change. My next iteration, it will go from 0.125 to 0.25. Clear?
Yes, ma'am.
Now again I calculated the middle point 0.1875. This comes out to be positive. In the next iteration 5, I just calculated 0.1875 to 0.25, and the midpoint was 0.21875. So this is a 5 iteration. I was supposed to go till 5th iteration. I need not to go for the 6th one, because in question he has explicitly mentioned perform 5 iterations. So of the 5 iteration, my approximation is 0.21875. Do you agree?
Yes, ma'am.
So my answer would be, after 5 iteration, approximated root is 0.21875. This would be my answer. So such type of questions would be asked in the examination. Clear? Earlier I just shown you the 10 iteration just to you to visualize कि as soon as we are going toward the higher number of iteration, our answer comes closer to the exact root. Just to visualize that. But in the exam, not more than 5 they would be asking you. Clear?
Yes, ma'am.
So you can go through this question. If you have any query, you can ask. Yes. Shall we proceed toward other question?
Yes, ma'am.
Okay. So next, now let us take one trigonometry question. Suppose perform 5 iterations of bisection method to obtain a root of equation fx is equal to cos x minus x e to power x is equal to 0 in the interval 0 to 1. Now I just would like to mention one thing here. Whenever you are dealing with trigonometric function, you always take x in radian. Clear? Whenever you
Yes.
would be doing the calculation, x should be in radian. Which calculator you are using, just set x to radian. Clear? Don't forget to do that.
Yes, ma'am. Yes, ma'am.
So again, I will visualize F0 and F1. They are of opposite sign as I have calculated. F0 is 1, which is greater than 0, and F of 1 is minus 2.1780, which is less than 0. So it means clearly the root lies in the interval 0 to 1.
Yes, ma'am.
So again, I will start forming the table. Number of iteration, an and bn endpoint, approximated root, sine of f of pn and f of an. Fine. So I have to go
Yes,
up to
ma'am.
5 iteration. So again, I have since calculated, so I am writing down. Otherwise, you guys have to do the calculation, then and write in the form of table. Okay? We are just
Yes, ma'am.
writing in the form of table. It is not necessary you have to write it. It's just for your clear visualization. Clear?
Yes, ma'am.
So midpoint is 0.5. When I check the cross sign, they are greater than 0. It means my interval would be, next interval would be 0.5 to 1.
Yes, ma'am.
So again, the midpoint is 0.75. I cross check the signs. That comes out to be negative. So it means now I would be 0.5 to 0.75. Clear?
Yes, ma'am.
Fine. The next we just calculate 0.625. So I again cross check sign of f of 0.625 and f of 0.5. Clear? So this comes out to be negative. So what should be the next interval? Tell me.
Ma'am, 0.5 to
Your
0.625.
voice is not audible to me. Could you please speak louder?
Ma'am,
Sir,
0.5 to
0.5.
0.625.
0.5 to 0.625. Clear. So again the midpoint is 0.5625. Sign again comes out to be negative. So what should be the next one?
And 0.5 to 0.5625.
5625. Correct. So when I evaluated the middle point, that is 0.53125, which is less than 0. So what would be my final answer? Yes.
Ma'am, 0.53125.
So this is the answer after 5 iteration. So this is the way bisection method works. Clear?
Yes, ma'am.
Any doubt with anyone? Yes. So I am just giving you one question for homework. Perform 3 iterations of bisection method to obtain a root of equation x cube minus 4x minus 9 is equal to 0. Okay? So just do this question, okay?
Yes, ma'am.
So you have to find out, I am not giving you the interval also, see? You have to first find out the interval, then you have to apply the bisection method to find out the answer. You have to go up to 3 iterations, clear?
Okay, ma'am.
So this was all about bisection method. So if you have any query, you can ask. Otherwise, I will proceed toward the next method, that is regular Falsy method. Yes. Yes. You want to ask something? or you just to visualize whatever we have done? Any problem, any question, anything you want to ask? Yes. So shall I proceed to next method?
Yes, ma'am.
So the next is regular falsy method. It is also one of the enclosure technique which I told you in the first lecture. What we do in regular falsy method, suppose this is our graph, fine, and say this is our chord. Okay. So suppose this is my point P, and the other is Q. So this is a chord PQ which is intersecting the graph y is equal to fx. Suppose it is intersecting the x-axis at point Pn. This is the graph y is equal to say fx, and we have drawn a chord joining 2 points on the graph, that is P and Q, and it intersects the x-axis at the point Pn. Is the graph clear?
Yes,
Yes.
ma'am.
So in regular falsy method, we would be actually, you can see y is equal to fx is intersecting the x-axis at this point, which I have marked with the red pen. So it means this is the exact root of the equation, fx is equal to 0. Yes.
Yes, ma'am.
And Pn is approximation to this root. So what we will try to do, we will start with Pn and we will slowly will move toward the exact root. This is my regular falsy method. Is it clear?
Yes, ma'am.
This is a regular falsy. Now how to find out the equation for Pn? Since we have an equation of a chord PQ, we have an equation of line passing through. Let's write down equation of line which passes through P and Q. So as you know, the equation of line is y minus y1 is equal to y2 minus y1 upon x2 minus x1 into x minus x1. Do you remember that?
Yes, ma'am.
So using that formula, equation of line would be y minus f of bn is equal to f of bn minus f of an divided by bn minus an into x minus bn. Is it clear? Equation of PQ line. Is this clear to everyone? Yes?
Yes, ma'am. Yes, ma'am.
Fine. So we have to find out the value of Pn. It means when I put x is equal to Pn, my y would be 0. Clear?
Yes, ma'am.
So substituting this point in the above equation, taking y as 0 and x as Pn, I will be getting this equation. Clear?
Yes, ma'am.
Solving it, Pn minus Bn would be minus f of Bn into Bn minus An divided by f of Bn minus f of An. So writing explicitly in the form of Pn. So it states that Pn would be Bn minus f of Bn, Bn minus An divided by f of Bn minus f of An. So this would be your final formula for calculating the approximations of the root. Is it clear? This is your regular falsy method. So we start up with the line PQ, which is an approximation to the exact root intersecting x-axis at Pn point. So we write down the equation of line PQ, and from there we'll find out the formula for the approximation of the root Pn, which I have marked as rectangle. Is it clear?
Yes, ma'am.
So
Ma'am,
this is the, yeah.
ma'am, can we write the equation of the line in terms of point P also, ma'am? Like using an and f of an.
Uh,
So will that make a difference, ma'am, if we do that?
how will you write down other way?
Ma'am, like y minus f of an using
No,
the
it
other
doesn't
point.
matter. It doesn't matter.
Okay,
You can
ma'am.
take any point. It doesn't matter.
Okay, ma'am.
The equation if point Q is also there, you can take that also. No issues. Clear? So this is
Yes,
the
ma'am.
formula for regular falsy method. So whenever the question comes, yeah, again I will tell you, whenever there is a question, there may be direct question. Solve the following equation by regular falsy method, or just write down the formula, or just state briefly what is regular falsy. In that briefly, this is the point which you have to explain. Clear? If he
Yes, ma'am.
asks you to explain something about this method, okay? Otherwise, you will start up with the formula direct. I show you one question how to solve by regular falsy method for the examination purpose. Suppose you are given solve the following question by regular falsy method. The equation is cos x minus x is equal to 0. Say in the interval 0 to 1. Now I have to apply regular falsy. It means I have to use the above method.
Yes, ma'am.
Clear? So first I will try to find out, again I will try to see whether the root lies in that or not. What is f0? That is cos 0 minus 0. That is 1. That root is greater than 0. And I will try to find out f1. So that is cos 1 minus 1. Clear? Cos 1 minus 1. So that I will try to find out. And my answer say would be minus 0.4596. It is less than 0. So certainly the root lies in 0 to 1 interval. Clear?
Yes, ma'am.
So now I have to find out first using the above formula. Whatever it is this, I will try to find out P1. So P1 by the above formula would be B1 minus f of B1, B1 minus A1 divided by f of B1 minus f of A1. Instead of n, I have put 1. You can see. Clear?
Yes, ma'am.
So now I will nothing but I will substitute the value because I know my A1 is 0 and B1 is 1.
Yes, ma'am.
A1 is 0 and B1 is 1. First iteration we are doing, we are trying to find out P1 through this method. Like in bisection method, it was the midpoint. But here I have to use this formula. So substituting all the values here and then calculating, the answer comes out to me 0.3149. So with A1, B1, I am able to calculate P1 using regular falsy method. Now again the bisection method technique, I have to calculate f of P1. That comes out to be by calculation 6359, which is positive. Now f of A1 is positive, f of P1 is positive, f of B1 is negative. It means the root will lie in P1 to A1, B1 sorry.
Yes, ma'am.
So my root in next iteration will lie in starting from P1 and ending at 1. So this would be my next interval. So you see the difference between bisection and regular falsy? Yes.
Yes, ma'am. Yes, ma'am.
So again, similarly, you have to just now find out P2. You know your new A2 and B2. So substituting the values in the above formula, it comes out to be 0.7126. You can check the calculation. Then f of P2 comes out to be positive. when you will find out. It means now the root will lie in which interval?
Ma'am, P2 to B2.
Root will lie in your P2 to B2. Clear? With P2 you find out f of P2 as 0.0352. So you can write here as the interval is 0.0352, comma 1. Clear? Okay.
Yes, ma'am.
So in this way, so this is the basic of regular falsy method. So basically, you have to just remember this formula, and then with substitution, finding out the initial a1, b1, you have to find out p1 by this. Then again, cross-checking the values at the end point, which interval will contain the root, freezing to that interval. Then you have to find out the next approximation. So basically, the value of the way of finding the midpoint of the interval changes to regular falsy method by this formula. In bisection method it was midpoint, but in RFM it is this formula for the approximation of the root. Are you getting the difference?
Yes, ma'am.
So this was regular falsy, which we will go further in next time. So that's all for today. If you have any query you can ask.
Ma'am, in this method also the iterations will be mentioned, ma'am, in the question.
Most probably, if it's most probably it would be mentioned, otherwise 3 or 4 iteration you can do maximum. Somehow in some way it may happen the examiner mix that in the question, so maximum you can go for 4 yourself, not after that.
Okay, ma'am.
Okay.
Yes, ma'am. And ma'am, in this paper, is calculator allowed, ma'am, in
Yeah,
numerical
calculator is a lot because there is a lot of calculation in this numerical method, so a lot of calculation is involved, so you have to use the calculator, it is allowed there.
Okay, ma'am.
Okay, so any other question?